You've got an exciting idea to build a new digital product. You start coding. You need a database. Everyone out there is talking about that new, ultra-scalable NoSQL database. I will also use it. You think. Halfway through the development, you realize that the hot, new database has a frustrating learning curve, a complex query interface, and is not at all suitable for the dataset of the application. You decide to dump it and settle down for a more proven solution. However, you have to pay a price. You must redesign your data model and discard some of the code that you have already written. This is going to impact your delivery timelines. You are not the only one who has had this bad experience. There are many types of databases out there, and they exist for different reasons. As a developer, it's your responsibility to select the correct one for your use case because an unfitting database will cost you time and money. In this video, we are going to discuss about the most common database types and their use cases. First, we must clarify the difference between relational database and NoSQL databases. Relational database and SQL are two frequently associated terms with databases, and there is a good reason for that. Relational databases were the prominent database systems until about 2009 from the 1970s. Relational databases are built on the relational model proposed by E.F. Codd, in a paper published in Communications of the ACM, in 1970. The original relational model defines a relation as a set of n tuples, where each tuple is an array of ordered columns. Most relational databases implement this model with some deviations. As an example, a table in a relational database corresponds to a relation with unordered columns. Let's see how we can model a student dataset consisting of students and their classes according to the relational model. The students relation has two tuples which correspond to two students. The classes relation has 5 tuples for 5 classes in the school. A student can attend many classes. This relationship is defined in student classes relation, which refers to tuples in the other two relations by ID. Structured query language or SQL was developed based on this relational model. Relational model and SQL paved the way for the development of very successful, widely used relational database software such as MySQL, MariaDB, PostgreSQL, etc. These relational databases have proved their capability by efficiently handling billions of records in many web and enterprise applications. The growth of Web 2.0 applications from 2004 started pushing relational database technology to its limits. Web 2.0 companies had to handle exponentially growing datasets consisting of billions and billions of records. To handle such huge data volumes, more CPU and memory are required. However, there is a certain limitation of CPU and memory that can be provisioned in a single machine. Beyond that, the only option is to scale horizontally, increase the number of servers. In a horizontally scalable database system, each machine in the cluster will own only a portion of the total dataset. The relational databases have problems with this type of horizontal scaling. Certain SQL operations such as join and group by can only be efficiently executed when the complete dataset is available in a single server. Also, preserving characteristics such as uniqueness become challenging when the dataset is split across the cluster. Therefore, a relational database works best when the dataset is replicated across all machines in the cluster. But that is inefficient. Driven by the requirement of web-scale companies to overcome these limitations, new database technologies began to emerge. These databases were inherently non-relational, so they did not support SQL. Therefore, they were called NoSQL databases, but a better name would have been non-relational databases. Unlike relational databases, NoSQL databases were designed to be horizontally scalable so that they could be scaled by splitting the database across many servers. As the NoSQL concept further evolved, many types of NoSQL databases were developed for specific use cases. Today, NoSQL has become an umbrella term to denote all these different types of databases. However, some developers believe that they must dump relational databases and should use only NoSQL. But that is a delusion. Also, since NoSQL has become an umbrella term, the belief that NoSQL is the only database you need does not help you to choose any one of those NoSQL databases out there. Next, we are going to discuss about these NoSQL database types and their use cases. Just keep in mind that new types of databases will be developed for new use cases in the future. As the name implies, a key-value database uses a simple key-value model to store data. The key has to be unique and the value could be anything such as numbers, strings, JSON objects, etc. Key-value databases do not process the value, so no queries can be executed based on the value. These databases do not support a query language as well. The values can only be retrieved based on the keys. React-KV and etcd are two open-source key-value databases. Amazon DynamoDB is a hosted key-value database from AWS. Here's how we could model students and their classes in a key-value database. Let's build this database with etcd. Etcd includes a command line client to interact with the database. We use the put command to create a key-value pair and the get command to retrieve the value of a key. Key-value databases are suitable for storing config parameters, in-memory data caching, managing session data in web applications, leaderboards, etc. Key-value databases are not suitable for applications that require complex queries and relationships. While it's not impossible to develop an e-commerce application or a blog with a key-value database, it may not be the best database for such use cases. A document database is an extension to the key-value database type, and stores data as documents with a structured format. A document could be structured in XML, YAML, JSON, or BSON to support binary data. Here's how we model a student dataset in a document database. A document database stores documents in groups or collections. Students is a collection in this database. We can add a second collection to store teachers' data. While a collection contains similar documents, each document in the same collection can have unique fields. We can add a new field, sports, to the first document in the students collection, without changing anything in the other documents in the same collection. Therefore, NoSQL databases are said to have a flexible schema. MongoDB is a popular open-source document DB that is also available as a cloud service. Amazon Document DB and Google Firestore are document databases in the cloud. This is how we create our student database with MongoDB. Unlike a key-value database which is unaware of the contents of the value, a document database processes and stores the contents of the document so that we can execute queries on the values stored in the document. Wide column databases store data in rows and columns like a relational database. However, unlike a table in a relational database, a wide column database defines columns per row. Therefore, each row in a wide column database can contain a set of unique columns. Tables in a wide column database can be split across multiple machines to support horizontal scaling. This is how we model the grades of the students in our student dataset in a wide column database. The set of columns starting with grades, in this model is called a column family. This column family has separate columns for each student based on the classes they take. While we use this model for demonstration, a wide column database is not the best database type for an application like a student database. A wide column database is a good fit for data sets with variable parameter types. You may not often get such datasets in common business applications, but they do occur in scientific and engineering applications. Fault alarms in a telecommunication network, event log of an application, and access logs in firewalls are some examples that will benefit from a wide column database. Wide column databases do not support SQL, but some wide column databases support a query interface called SQL, Cassandra Query Language. While SQL looks somewhat similar to SQL, it does not support join operations. Apache Cassandra is an open-source wide-column database and Google Bigtable is a wide-column database offered as a service from GCP. Graph databases excel at handling highly connected data sets. A graph database stores data as nodes and relationships, making the relationships instantly available for queries. Relational databases handle connections via one-to-many or many-to-many relationships and join operations. This may be efficient enough for first- or second-degree connections but falls short beyond that. A graph database can effectively handle datasets with connections that extend beyond 20 or 30 degrees. Let's model our student dataset for a graph database. Graph databases are suitable for use cases like recommendation engines, access and user management systems, fraud detection systems, etc. Nebula Graph and Neo4j are open-source graph databases that are also available as cloud services. Amazon Neptune is a graph database service from AWS. A time series database is a specific type of NoSQL database optimized to store a series of metrics or events with a timestamp. You may use a relational or a document database to store such data. But time series datasets have some unique requirements like aggregating, archiving old data, etc., which cannot be effectively done with relational or document types of databases. Therefore, a purpose-built time series database is more efficient than other databases for storing time series data. A time series database stores data in columnar format, so it can split data across multiple servers to support horizontal scaling. It is a write-many-read-less type of database, as data points in a time series database would be occurring continuously and need to be written to the database at the same rate. It's impossible to adopt a time series data model for a student database. So, let's assume Hal and Roger are trying to record weather data from an IoT device. The first device, named Dev1, can measure relative humidity. So, we design the time series database with a single series with key Dev1 humidity. Several days later, Hal and Roger set up a new device, Dev2, which can measure both humidity and temperature. So, we add two new series with keys Dev2 humidity and Dev2 temperature. The beauty of the time series databases is that we do not have to mess with the existing data to add the new series. Also, this data model will easily scale to millions of devices. If newer devices come with more measurement capabilities, we can quite efficiently incorporate those measurements as well. Prometheus and ReactTS are two popular open-source time series databases. InfluxDB is an open-source time series database that is also available as a cloud service. Search engine databases are purpose-built for searching textual contents. This is equivalent to an internet search engine, so it is named as a search engine database. A typical search engine database analyzes the text contents and creates indexes, similar to an index in a book. When a search is executed, the database can quickly find the mapping content via this index. Search engine databases are helpful for full-text searching in news websites, blogs, software documentation, etc. Log file analysis is another important use case of search engine databases. Typical log files contain a textual description of a certain event or fault in a system. A search engine database can search and correlate log files from multiple sources to yield insightful results. Again, a search engine database is by no means applicable for a student database. So, let's assume that Hal and Roger are using a search engine database to index a set of documents on African wildlife. There can be any number of documents. Since we are interested in wildlife, we are creating the index based on animal names. Whenever a new document is added, the database will update the index. We can query the database using animal names, and quickly get the response containing the documents where the respective names are mentioned. Apache Solr is an open-source search engine database. Elasticsearch is another open-source search engine database that's also available as a hosted service in AWS and GCP. Algolia is a search engine database that is offered as a hosted solution. Navigating digital maps has become a part of our everyday lifestyle. Digital maps are required to store and process spatial data that represents geographic locations on Earth. There is a series of standards defined in ISO TC 211 for spatial data representations. These spatial datasets are stored in spatial databases. Navigation is the most common use case of digital maps. But digital maps are used in other applications like civil engineering, telecommunication network planning, seismic surveys. The spatial datasets in these maps need to contain information such as elevation, building infrastructure, soil condition. Spatial databases with support for specific types of information will be required for these kinds of use cases. Often, a spatial database is a relational or a non-relational database, enhanced to store spatial data. GeoMesa is such a toolset that enables spatial data support in Google Bigtable, Cassandra, HBase, etc. PostGIS is also an open-source extension that adds the geospatial capability to PostgreSQL. Some applications, called polyglot persistence applications, depend on multiple types of datasets, so using one specific type of database is not efficient. As an example, a social media application may have one dataset that is best suited for a relational database and another dataset that requires features of a graph database. While they benefit from using different database technologies, using several databases leads to synchronization problems and operational overhead. Multi-model databases solve this problem by merging the flexibility of NoSQL and the features of relational databases. These databases support executing queries in relational or non-relational models. Most multi-model databases available today are extensions built on top of previous relational or NoSQL databases. An example is the JSON support added in PostgreSQL. FaunaDB is a multi-model database that is available as a service. Couchbase, which is primarily a NoSQL database, offers many features of a relational database. A database is an integral part of any web, mobile or enterprise application, and most often is the limiting factor of scalability. Once an application is in operation, swapping the database is no easy task. Therefore, you must ensure that you are choosing the best database right at the beginning. The best database for your application is not necessarily the most scalable or the most popular database out there. Your use case determines the type of data you are working with and the scale. So, your use case is the most important factor for your decision about the database. The database you choose must have a fitting data model for your dataset. It must also allow you to efficiently query the data according to the requirements of the application. This must be re-emphasized. There is no silver bullet database. Different databases exist for different reasons and use cases. You must thoroughly analyze your use case and select the most appropriate database. If you settle down on a database just because it's the new trend in industry, chances are that you will regret your decision. NoSQL databases have created lots of industry hype due to their scalability. It's true that NoSQL databases are designed for scalability. But it does not mean that relational databases are not scalable. There have been many developments recently that improve scalability of the traditional relational database. Keep in mind that the scalability of NoSQL will not help you, if your data model cannot fit a NoSQL database. A wrong decision with the database will definitely impact your application launch. You do not want to miss your launch deadline just because you were messing with the most powerful database technology on the planet.